everyone. I am Dr. Lakshmi Priya Swami, Assistant Professor, Department of Mathematics from SR University. Today I am going to discuss about Cayley-Hamilton theorem. Now I'll explain the Cayley-Hamilton theorem, which is one of the most important result in linear algebra. The statement of the theorem says that every square matrix satisfies its own characteristic equation. What does this mean? If we find the characteristic polynomial of a square matrix A and then substitute the matrix A itself to the polynomial, the result will be zero matrix. In simple words, the matrix behaves like the roots of its own characteristic polynomial here. Now let us look at the most common application of this theorem. First, we use it to find inverse of a matrix. Instead of using long adjoint method, we can express the inverse of in terms of power of A, which is simplify the calculations. Secondly, it helps to finding the integral power of matrix such as AQ, a to the 4, a to the 5 and so on. Using the characteristic equation, we can reduce higher power into lower powers. Third, we can express any large power of A in terms of lower powers of like I, A square. This is especially useful in solving systems of different differential equation, difference equation and engineering applications. So overall, the Cayley-Hamilton theorem is not just theoretical, it is very powerful in practical matrix calculations also. Now I'll explain example 1. Here verify Cayley-Hamilton theorem for the matrix A here. This one is given. Now we have to verify Cayley-Hamilton theorem. So first write the matrix here and find the characteristic equation. How to find the characteristic equation? Simply determinant of A minus lambda I equal to 0. So we get the characteristic equation. First you have to find A minus lambda I. And here this I is nothing but the unit matrix. 2 cross 2 unit matrix. What is 2 cross 2 unit matrix? That is simply like 1 0 0 1. This is your 2 cross 2 unit matrix. So simply you have to this is your I. Simply you have to multiply lambda here. Do the scalar multiplication lambda here. So you get a lambda 0 0 lambda. Then simply subtract from A to lambda I. You get this matrix. Now do the determinant of this matrix. Simply cross multiplication of this. So you get this equation. When you solve this, then finally this is your characteristic equation of A. So now you have to verify the Cayley-Hamilton theorem. For that, instead of lambda, you put in the place of lambda, you put A. So you get A square minus 8A plus 13. So that equate to 0. Now we have to verify that A square minus 8A plus 39 equal to 0 or not. So first you have to find A square. How to find A square? Already given matrix A is given. This is your matrix A. This is your matrix A. So simply multiply this matrix to itself. So you get A square. How to multiply two matrix? Like first row multiplied with first column, so you get this position. Simply first row multiplied with second column, so you get this position. Second row multiplied with first column, so you get this. Second row multiplied with second column, so you get this. After calculation, you find A square. Then simply you have to put A square minus 8A plus 39. This is your A square. Right here A square minus 8, and A is nothing but your given matrix. So you write A here plus 13I, and here I is what? I is unit matrix. So simply write 1001. Then do the calculation. Like first A1 1 place right here minus 8. Multiply this column. Do this column multiplication here. So you get 8 into 3, that is 24. Then here 13 into 1, that is 13. So simply you have to do the calculation. So you get 0 entries in every 0 in every entry. So you get 0 matrix. So this is verified. Now this is one more example to verify Cayley-Hamilton theorem. This is a 3 cross 3 matrix. Now you have to verify that. First, in this type of question, first you find out the characteristic equation, that is A minus lambda. Here this I is unit matrix, 3 cross 3 unit matrix. What is the 3 cross 3 unit matrix? Simply you write the 3 cross 3 matrix. I is equal to 1 0 0 0 1 0 0 0 1. Now you have to do the scalar multiplication with lambda with I. So you get lambda 0 0 0 lambda 0 0 0 lambda. Simply you have to subtract from this matrix to lambda I. You get this type of matrix. Now you have to do the determinant of that matrix. All of you know how to find the determinant. Simply write this matrix and this entries 1 minus lambda, and now you have to remove this place and this place. So you get and find the minor of this. So you find this. Simply now in the second place you take minus 2, take negative of 2, and simply you have to remove this column and this row and find the determinant of the minor. Simply you have to find do the calculations like this. Then you have to simplify this. So you get this type of cubic equation. Now this cubic equation is nothing but your characteristic equation of A. So now for the verification of Cayley-Hamilton theorem, you have to put in the place of lambda, you have to put A. So you get the equation like AQ minus 6A square plus A plus 25, that equal to 0. Now you have to check that this equation left hand side is equal to 0 vector or not. For that you have to find first AQ, A square, and put all the values in the place of AQ, A square and A, and you get, after calculation, you get 0 vector. Then only it is verified. Now for the verification, we have to verify that this equation left hand side it is equal to 0 or not. So for that you have to find A square first, then multiplied A square with A, you get AQ. So multiplied find A square, this is the matrix A, so multiplied itself, this matrix with itself, so you get this. How to find the multiplication of these two matrix? Simply do the multiplication like first row first column multiplied, then you get this position, first row second column you get this, first row third column you get this. In this manner you find first second row first column you get this, second row second column you get this, second row third column you get this position. In this manner you have to find this third row also. After calculation you find A square. Simply when you find A square, multiplied A into A square, so you get AQ. So AQ is, you have to find AQ, A square. If both of the calculation is complete, now you have to put the value of AQ, A square and A here, do the calculation. Let's see in the next slide. Now you have to put in the place of AQ, A square, A and I. This is AQ and this is A square, A, and this is nothing but your unit matrix I. Now you have to do the calculation in each entries. So this is 28 minus do the scalar multiplication means multiply 6 into each entries. So this is 6 into 9 minus 54 plus 1 plus 25 multiplied with each entries here. So you get 25 here. In this manner you have to do the calculation in each entries. So you get 0 matrix here. So the theorem is verified now. So this is one more question to verify Cayley-Hamilton theorem. Find the characteristic root. So this is your matrix A. Now you have to verify that Cayley-Hamilton theorem. But here this equations matrix solved by using row or column operation. Simply you have to do the row operations here. First you have to write the characteristic equation of A, that is nothing but your A minus lambda I determinant equal to 0. So all of you know how to find this. So in the previous I'll discuss two questions on that, how to find this A minus lambda I I'll discuss. So this is your A minus lambda I. Now you have to find the determinant, but here by using row operation or column operation you have to find the determinant. So for that you have to do the operations here, like row 1 minus row 3, row 1 minus row 3. So you get row 1 tends to, here some mistakes is here, row 1 tends to row 1 minus row 3. So you change this entire row by using these operations and write second row and third row as it is. Now you have to do one common from this row, that is lambda plus 1. So you get minus 1 here, 0 here and 1 here. Now do one column operation here, that is column 3 plus column 1, column 3 plus column 1. So you get 0, 4 and 3 minus lambda here. Now this 2 places 0, so the calculation is very easy. Like first only first place you have to consider minus 1 into, remove this rows and this column and do the find the minors of this. This is the final answer. So one is lambda plus 1 and this one is the quadratic equation. You have to solve this quadratic equation. First you have to multiply this, so you get this characteristic equation first. After that, this is the one of the root lambda plus 1 and this one is another quadratic equation. When you solve this quadratic equation, you get value of lambda, that is 2 value of lambda, that is one is 5 and another is minus 1. These three values are characteristics root or eigenvalues. So this is the characteristic equation you have to find, and this manner by using the row operation and column operation you get this characteristic equation. Now you have to verify that. So for the verification you have to put in the place of lambda you have to put a here. So you get minus a cube plus 3a square plus 9a plus 5 equal to 0. So when you verify this, once you have to check left hand side is equal to 0 vector or not. If it is 0 vector, then it is verified. Let's see in the next slide. So now you have to do the verification. You must have a cube minus 3a square minus 9a minus 5 equal to 0. So left hand side, right here, a cube minus 3a square 9a minus 5. So now find the value of a cube. Simply find first a square, multiplied a with a matrix with itself, so you get a square. Then aq is nothing but multiplied a square with a. In this manner you have to find aq. So this is your aq and this is your 3a square and this is 9a and this is 5i. So to find all these things and put the value here and do the calculations, like in the first place of this, first place of this, and first place from this matrix and first place from this matrix. So you get this, in this matrix you get 1 1 position, you have to do the calculation, so you get 0 in the 1 position. In the similar manner, you have to find all the calculation in each entries, so you will get 0 in each entries. So this is nothing but your 0 vector equal to 0. So this Cayley-Hamilton theorem is verified here. This matrix is satisfied Cayley-Hamilton theorem. Now we'll move on the next question. Now in this example, I'll discuss verifying Cayley-Hamilton theorem and find the inverse. This is the one of the application of Cayley-Hamilton theorem. So this is already the matrix is given here. So the first step is find the characteristic equation of this matrix. So how to find there is this is one type of typing mistake here. This is a minus lambda I equal to 0. Determinant of a minus lambda equal to 0. So this is your A, and here I is what? Unit matrix 3 cross 3. Here I is 3 cross 3 unit matrix. So simply you have to do the scalar multiplication with I and subtract A from a lambda I. So you get this matrix. Once you solve this matrix, so you get characteristic equation. This is your characteristic equation. For the verification, you have to do in the place of lambda, you have to put A here. So you get A cube minus 5A square plus 13A minus 9 equal to 0. And in the place of lambda, you put A. In the place of lambda, you put A. So you get this equation, A cube minus 5A square plus 13A minus 9I equal to 0. There is nothing to discuss here, because in the previous also I'll discuss how to verify that. Simply you have to put A cube, A square, A in the place of this in this equation, put all the value and solve the do the calculation, you get a 0. So for the A square, simply do the calculation like A multiplied with itself, so you get A square. For the A cube, you multiply A square into A, so you get A cube here. Put all the values in the place of A cube, A square, A and I, and do the calculation place wise, so you get a 0 in each entry. So this is verified. Now I'll discuss in the next class, next slide, how to find the inverse by using this Cayley-Hamilton theorem. So now this is your characteristic equation. For that characteristic equation, in the place of lambda, you have to put A. So you get this equation. Now you have to multiply A inverse. Multiplied A inverse in this equation. So you get A inverse, multiply A inverse in each place, like minus 5 A inverse into A square plus 13 A inverse into A minus 9 I A inverse equal to 0. So here simply do the calculation. If both the here minus 1 is available here and 3. So do the calculation like A to the power, if these two are same, so do the calculation here like 3 minus 1 2. So you get A square. Simply A to the minus 1, A to the 2. So 2 minus 1, that is 1. 5A. Here A inverse into A. This is nothing but your I. All of you know A inverse is equal to I equal to A inverse into A also. So you have to write I here, and I into A inverse, that is A inverse equal to 0. Now simply do the calculation like write A inverse one side and write A inverse 9 A inverse equal to A square minus 5A plus 13I. Then A inverse is equal to nothing but 1 by 9 of this one. Now you have to put all the values of, in the place of a square you have to put a square value. And now this one is one more example. In this type of scenario based questions are coming into exam. So like this matrix A is given. This is 2 cross 2 matrix is already given. Use the Cayley-Hamilton theorem to compute integral power of e to the power 4. Explain how expressing higher power of a using the help of analyzing variation behavior and system stability. Let's discuss. Now, do the solution like this is the step 1. In the step 1, you have to find the characteristic equation first. That is nothing but your determinant of a minus lambda equal to 0. So, in the place of a, you write a here, and this I is nothing but your 2 cross 2 matrix. So 1 0 0 1, so you get lambda 0 0 lambda. Subtract this, you get this matrix. Now you can simply do the determinant. How to find the determinant of this? Simply do the cross multiplication, so you get this. So this is your, now this is your characteristic equation. And in the step 2, apply Cayley-Hamilton theorem, replace lambda with the matrix A. So you get a square plus 3a plus 2y equal to 0. This is nothing but your Cayley-Hamilton theorem equations. Now this is the step 3. In this step, express higher powers using the theorem. So higher power is nothing but your a square. So you have to write a square is equal to minus 3a minus 2y. Now you have to compute aq. For aq, multiply a with a square. So you have to write a here, and this one is nothing but your a square. So write the value of a square here. So you get this. Now substitute a square is this in this place. Substitute a square, this value, in this place. So you get this minus 3aq equal to minus 3, this one minus 2a. When you solve this, so you get aq 9a plus 6i minus 2a. When you solve this equation, so you get aq equal to 7a plus 6i. So for compute a to the power 4, you have to multiply a with aq. In the previous, we will discuss how to find aq. So write the value of aq here. When you calculate 7a into a, that is 7a square, plus 6i into a, that is 6a. Substitute a square, this one is your a square, in the place of this. So you get 7 into minus 3a minus 2y plus 6a. So a to the power 4 is equal to nothing but minus 21a minus 14i plus 6a. When you solve this, so you get a to the power 4, that is nothing but minus 15a minus 14i. The step 4, substitute the matrix value. So a to the 4 is equal to minus 15. Simply put the value of the given matrix A is already given in the question. So you write the matrix A here, and I is nothing but your unit matrix right here. When you solve this, so you get a to the power 4 easily. Now this one is the one more question, and this question is a 3 cross 3 matrix. Using this Cayley-Hamilton theorem, determine A inverse. Yeah. So this one is your, this matrix is already given into your question. Now you have to solve. First, in the first step, you have to find the characteristic equation of A. That is nothing but your A minus lambda equal to 0. So all of you know how to find the characteristic equation. So this is your equation expanding all the first row. So you get this type of equation. This equation is your characteristic equation. For the verification, you have to replace in the place of lambda, you have to replace a, so you get this equation. Now you have to multiply a inverse in this equation. So you get, when you multiply a inverse, so you get a inverse into aq minus 4 a inverse into a square plus 5 a inverse into a minus I into a inverse equal to 0. So this is your a square, 3 minus 1, that is 2, 2 minus 1, that is 1. So you have to write 4a, there is a mistake, 4a A inverse of A, that is nothing but your unit matrix I. So write 5i minus A inverse equal to 0. So what is A inverse? Simply take it another side. A inverse equal to A square minus 4A plus 5i. Now compute A square. A square is what? A square means A into A. The given matrix multiplied with itself. So you get A square. Now put the value of A here and this I. This I is a 3 cross 3 in a matrix. When you put all the values in the place of A square, A and I, you get A inverse. In this manner, you have to find easily the inverse of a given matrix by using the Cayley-Hamilton theorem. Now, this one is the one more question for Cayley-Hamilton theorem. Here, you have to find the value of C plus D. Already in the question, matrix is given. During the analysis, the engineer discovered that the system follows a special algebraic relation involving the matrix inverse. 6A inverse equal to A square plus CA plus DI, where C and D are constant and I is the identity matrix. To better understand the system behavior, the engineer need to determine the complete of this constant. So the question is here, find the value of C and D. This C and D, these two constants you have to find in this question. Now we'll discuss how to find the C plus D. For that, you have to find the characteristic equation first. For the given equation, this one is your characteristic equation, A minus lambda equal to 0. So first you have to find the characteristic equation. In this in the previous already 4 to 5 question I'll discuss. So I thought there is no doubt how to find the characteristic equation. This is the characteristic equation. Now in the next slide I'll discuss how to find C plus D value. So in the previous I'll discuss how to find the characteristic equation. In the next step you have to replace, in the place of lambda you have to replace A. So you get A cube minus 6A square plus 11A minus 6I equal to 0. Now you can do one thing. Let's like in the next step you have to do one thing. Write like A cube minus 6A square plus 11A equal to 6I. Then to do like let's here everywhere is A is available, so you write one common A here, so you get A square minus 6A plus 11. There is nothing means you have to write I equal to 6I. Now you have to multiply A inverse both the side. Then you get A inverse into A equal into A square minus 6A plus 11I equal to 6I into A inverse, that means A inverse. So here A inverse into A is nothing but your I, that means 1. So you have to write A square minus 6A plus 11I equal to 6A inverse. Then already in the previous in the questions this format is already given, like 6A inverse. In the question is given like 6A inverse equal to A square minus CA plus D. Now you have to find the value of C and D. Look here, the questions are also look like 6A inverse A square minus, this place is nothing but your C value, and this place 11I means 11, that is nothing but your D. So in this manner you have to find C equal to minus 6, D equal to 11. Now you have to calculate C plus D. It is very easy. So put in the place of 6 is minus, C is minus 6 and D is 11. So you get C plus D equal to 5. So in this manner you have to find the value of the constant. And the questions already, this type of questions are coming. So simply do the find out the characteristic equation and then replace the value of in the place of lambda you have to replace a and do the calculation in this manner. So you have to get the constant value. In this video, I'll discuss all the questions, whatever may be possible questions are coming in the how to verify Cayley-Hamilton theorem for 2 cross 2 matrix, 3 cross 3 matrix, and find the value of constant, all these things. If you have any doubt, so please write in the comment box. Thank you.